do we synthesize alcohol using Grignard reagents? As I have been mentioned before, alcohols can be synthesized from Grignard reagent using carbonyl compound and Grignard reagents. But the final product of the reaction is determined from the starting material that we use for the reaction. So the first reaction here is using formaldehyde. Okay, when we react formaldehyde with Grignard reagent, what will happen? We have the R minus here. So this R minus a nucleophile which will attack the C carbon here, the carbon here, and then the electron will move from the pi bond to the oxygen. So it will give you an alkoxide ion here, and this oxygen will abstract proton from the acid, and then it will give you a primary alcohol. Note that it is primary alcohol because the Grignard reagent only has one R group, while the formaldehyde does not have any R group. So you can see at the primary alcohol here only one R group, which comes from the Grignard reagents. The second example, when we use higher aldehyde, it will result in a secondary alcohol. If you notice that, what makes it secondary alcohol? Because we have one R group from the Grignard reagents and then another R prime group from the aldehyde group, from the aldehyde compounds, and what we get is secondary alcohol with one R group from the Grignard reagent and R prime group from the aldehyde that we use. And if you look at the third example here, the starting material that we use is ketone. So we know that ketone has two R group, which is R prime group and R double prime group. So when we react this ketone with Grignard reagent, so what we will get is a tertiary alcohol which has R group, R prime group, and R double prime group. Other than formaldehyde, aldehyde, and higher ketone, we can also use esters to react with the Grignard reagent, which give you a tertiary alcohol as well. However, the difference between ketone and ester, so in Grignard reaction, when we use ketone, we only use one equivalent of Grignard reagent. But if we choose ester as our starting material, we need to use two equivalent of Grignard reagent, meaning one equivalent here and then another equivalent is at the second step. So why do we need 2 molar equivalent of Grignard reagent? So in this case, the first molar equivalent will convert the ester into ketone first, and then once it becomes ketone, it will react to the second molar equivalent of Grignard reagent to give a tertiary alcohol using the same mechanism proposed at the previous slide. This is some of the example of how we can prepare specific types of alcohol using a reaction with formaldehyde and higher aldehyde. Okay, if we look at the first example here, we use phenyl magnesium bromide and we react with a formaldehyde using ether solvent, and we will get this magnesium bromide halo alkoxide, and then we add acids to give a benzyl alcohol. So how does this reaction work? So this is the R minus, so R carbon ion. So this R carbon ion will attack this carbon because this carbon is partially positive, and then the electron here will shift to the oxygen, and what we will get is CH2 from the Grignard reagent and C6H5 from the Grignard reagent and CH2O from the formaldehyde. And then what will happen if we have acids is the oxygen will abstract the proton from the acid, and then this bond will move to the oxygen, and we will get benzyl alcohol at 90% yield, which is quite high. Okay, at the second example here, we look at the reaction with a higher aldehyde. So this is the R carbon ion, which is the nucleophile. So it will attack this carbon, and then this electron will move to the oxygen. So it will give you an alkoxide here. So this alkoxide will abstract the proton from the acid, and then it will give you a secondary alcohol, which is 2-butanol. And if you look at the group here, the R group, the CH3CH2 comes from the Grignard reagents, while the CH3 here comes from the higher aldehyde. And then we have a reaction with ketone. Okay, for example here, we have butyl magnesium bromide. So we are going to react this Grignard reagent with acetone, which is the ketone, and then what will happen is that this will form R minus, and it will attack this carbon, and then this carbon will move to the electron will move to the oxygen, and we will get this alkoxide. And as usual, the oxygen minus will abstract the proton from the acid that we use, and then we will get a tertiary alcohol as what you can see in the slide. Okay, the next reaction is when we have a Grignard reagent react with an ester. Note that the difference between reaction with a ketone and ester lies in the molar equivalent of the Grignard reagent used. Okay, in this case, we are going to use two molar equivalent of Grignard reagent. So if you look at the reaction here, the ethyl magnesium bromide is now reacted to the ethyl acetate. At the first step, it will give you a ketone. It will give you ketone, and then after the ketone is formed, it now react with another molar equivalent of the Grignard reagent to give you an alkoxide compound here, which will then the oxygen will abstract the proton from ammonium chloride, and it will give you a tertiary alcohol as well. However, we have mentioned about the reaction of a Grignard reagent with formaldehyde, higher aldehyde, ketone, and also ester. So another carbonyl functional group that we have not looked at is carbon dioxide, where if we have carbon dioxide, it can react with Grignard reagents and give carboxylic acid. So in this case, if you have the R minus here, it will attack this carbon, and then the oxygen will move, the electron of the pi bond will move to the oxygen, and then it will give you O minus here. So this O minus will abstract this proton, and it will give you carboxylic acid.